In this next example, we'll explore an important concept in PHP programming, the use of the global keyword. This concept is often misunderstood by beginners, but once you understand how it works, you'll have much more control over how data moves through your program. Let's take a look at code snippet 9. Here, we start by defining two variables, x1 with a value of 25 and y1 with a value of 10. These two variables exist in the global scope, which means they can be accessed anywhere in the script, except inside a function, unless we specifically make them available. Next, we create a function named myTest. Inside this function, we use the statement global x1, y1. What this line does is very important. It tells PHP that inside this function, both Huzaifa and y1 should refer to the same global variables we defined earlier, instead of creating new local copies. In simple words, the function is now directly connected to those global values. After declaring them as global, the next line performs a simple operation, when e x b. Here, PHP adds 25 and 10, which gives us 35. Because y1 inside the function refers to the global y1, the result, 35, updates the global variable as well. When we later call echo y1, outside the function, the output displayed will be 35. Now let's pause and understand what's really happening behind the scenes. Normally, variables declared outside a function are not accessible inside it. PHP treats each function as a separate space, a local scope. But when we use the keyword global, PHP links the local variable name to the global one. This means any change inside the function directly affects the global variable. Technically, it's similar to writing globals, plus globals. One where globals is a special associative array that holds all global variables. This mechanism is powerful, but it comes with risks. Using global variables too often can lead to confusing code. Since global values can be changed from anywhere in the program, debugging becomes more difficult. Functions lose their independence and start depending too much on external variables. This makes your code less predictable and harder to maintain, especially as projects grow larger. In most real-world applications, it's better to avoid using global unless absolutely necessary. Instead, you can pass values as function arguments and return the result. For example, you could rewrite the same program as function add a, b, return a plus b, me. Then simply call y1 and add x1, y1, and echo the result. This approach is cleaner, easier to test, and avoids unwanted side effects. If you really need to modify a variable inside a function, a better option is to pass it by reference. This makes it clear that the variable will change. For instance, you could define function myTest and x plus yy, and then call myTest 1x1. It achieves the same outcome but is more explicit and safer to maintain. For larger projects, a more professional approach is to use objects. You can create a class to store your data and perform operations on it. This encapsulates the state, making the code modular, testable, and easier to understand. In this code snippet, the global keyword allows a function to access and modify variables that exist outside its local scope. The output is 35 because the function directly changes the global value of y1. However, in practice, using global variables too frequently can lead to unpredictable behavior and hidden bugs. It's usually best to design your functions so they receive values as input and return results, keeping your data flow clean and transparent. Always remember, use global variables carefully. Understand their effects and prefer functions or classes that handle data explicitly. This not only improves your program structure, but also helps you write professional, error-free, and easy-to-debug PHP. As you can see on the screen, when this program runs, the output displayed is 35. This confirms that our function has successfully accessed and modified the global variable using the keyword global. Here, the function myTest takes the two global values, x1 and y1, adds them together, and stores the updated result back into y1. When the function is called, the statement y1 x1 plus y1 is executed using the global variables. The value of x1 is 25, and the value of y1 is 10. After performing the addition, the new value of y1 becomes 35. Then, when the program reaches the echo statement, it displays this updated value on the screen. This simple example clearly demonstrates how the global keyword allows a function to access and manipulate variables that exist outside its local scope. Normally, functions can only use variables declared inside them, but by using global, we give the function permission to use and change variables defined in the main script. However, while this behavior can be useful in certain small programs, it's important to be careful. Relying too much on global variables can make your code harder to manage and debug, especially in large projects. A small mistake can easily overwrite important data because global variables can be changed from anywhere in your program. So, the key takeaway here is this. The global keyword is powerful, but it should be used wisely. In professional programming, it's usually better to pass values into a function as parameters and return results, instead of directly modifying global variables. That way, your code becomes cleaner, safer, and easier to understand. Now that we've seen how the global keyword allows a function to access variables from outside its scope, let's move to another important concept. The static keyword in PHP static variables are used when you want a local variable to remember its value even after the function has finished executing. Normally, when a function ends, all its local variables are deleted from memory. But when a variable is declared as static, it keeps its value between function calls. To create a static variable, you simply use the static keyword before the variable name while declaring it inside a function. For example, static count 0. This means that count will be initialized only once, and every time the function is called again, it will remember its previous value instead of starting over from 0. Let's look at the example shown here. The function incrementCounter has a static variable count, which starts with the value 0. When the function is called for the first time, count is 0, and after incrementing, it becomes 1. On the second call, count is no longer reset. It starts from the previous value of 1, then increments to 2. Similarly, on the third call, it becomes 3. This clearly shows that the static variable retains its value across multiple function calls. Each time the function runs, the variable is updated but not destroyed when the function exits. However, it's important to note that even though the variable persists, it is still local to the function, meaning it cannot be accessed from outside the function directly. In short, the static keyword allows a function to remember data between executions without relying on global variables. It's especially useful in situations where you want to track something, like the number of times a function is called, or preserve data temporarily, without making it accessible globally. Using static variables makes your code cleaner and avoids the risks associated with global variables, such as accidental modification or naming conflicts. It gives you the best of both worlds, persistence like a global variable, but privacy like a local variable. Let's now look at code snippet 10 to understand how the static keyword actually works in action. In this program, we have a function called myTest. Inside this function, a variable AX is declared as static and initialized to 0. This means that EX will be created only once, and it will retain its value between function calls. Each time the function is executed, PHP does not reinitialize by X. Instead, it continues from the value it held previously. Within the function, the statement echo AX displays the current value of @x, and the next line, x++, increases its value by 1. After defining the function, myTest is called 3 times in the script, with a line break printed between each call. Here's what happens step by step. When myTest is called the first time, x is initialized to 0 and printed. Then x++ increments it to 1. On the second call, AX is not reset. It still holds the value 1, so it prints 1 and increments to 2. On the third call, X now starts from 2, prints it, and increments to 3. So, the output on the screen will be 0, 1, and 2, each appearing on a new line. This perfectly demonstrates how static variables preserve their state across multiple executions of a function. Unlike normal local variables that disappear after a function ends, static variables remember their last value. However, they remain local to the function, meaning no other part of the code can access them directly. In practical terms, this feature is very useful for keeping track of function calls, counting operations, or storing temporary data that should not be lost between calls but also shouldn't be exposed globally. In Code Snippet 10, the static variable ereg acts like a small memory inside the function, remembering where it left off each time the function is executed. This is a powerful concept that helps you manage state within a function without depending on global variables. Now that we've covered how PHP handles global and static variables, let's move on to another powerful concept used in text processing: regular expressions, often referred to as regex. Regular expressions are a special sequence of characters that describe a specific search pattern within text. Think of them as a smart way to search for, match, or even replace parts of a string based on a rule you define. They're widely used in programming for operations like validating input, searching through large chunks of data, or filtering specific words and patterns. In simple terms, regular expressions allow you to define a pattern, and then PHP can use that pattern to find matching text. This makes them extremely useful for tasks such as checking if an email address is valid, identifying phone numbers, or extracting specific words from a paragraph. In PHP, a regular expression is written using delimiters, a pattern, and optional modifiers. The general syntax looks like this: exp as elite schools I. Here, the / aux is the delimiter, which marks the beginning and end of the regular expression. The word elite schools is the pattern you're trying to find, and the letter I is a modifier that makes the search case insensitive. This means that PHP will match the word elite schools, whether it appears in lowercase, uppercase, or a mix of both. Delimiters are simply special characters that tell PHP where your regular expression starts and ends. The / aux is the most commonly used one. However, if your pattern itself includes slashes, you can use other delimiters like the hash symbol, drax, or the tilde to avoid confusion. Essentially, regular expressions are a compact, powerful way to describe how text should look, and they allow PHP to fetch or manipulate data with precision. They might look complex at first, but once you understand how patterns, delimiters, and modifiers work together, they become one of the most efficient tools for handling text-based operations. In PHP, there are two main types of regular expressions, each with its own style and syntax. These are POSIX regular expressions and PERL-style regular expressions. Let's understand the difference between the two. POSIX regular expressions were the original form used in older versions of PHP. They follow the POSIX standard, and which stands for Portable Operating System Interface, POSIX. Expressions are written using functions that start with the prefix ereg, such as ereg, ereg, and ereg replace. These functions are simple and easier to read, but they are also slower and less powerful compared to modern alternatives. Because of this, POSIX-style expressions are now considered outdated and were actually deprecated in newer versions of PHP. On the other hand, PERL-style regular expressions, also known as PCRE, which stands for Perl-compatible regular expressions, are the modern standard used in PHP today. They are much more flexible, faster, and powerful than POSIX. PERL-style expressions use functions that start with the prefix preg, such as preg match, preg replace, and preg split. These functions allow for more advanced pattern matching, complex search conditions, and the use of modifiers that enhance functionality. To give a quick comparison, if you want simple matching in older scripts, POSIX expressions can work. But for any modern PHP application, PERL-style regular expressions are strongly recommended. They are the standard approach today and are widely supported across all versions of PHP. While POSIX regular expressions were the early method used in PHP, the PERL-style regular expressions have completely replaced them due to their speed, efficiency, and advanced capabilities. As you continue learning, always focus on preg functions, as they represent the current and most powerful way to use regular expressions in PHP programming. Now let's take a closer look at the first type, POSIX. Regular expressions. POSIX stands for Portable Operating System Interface for Unix. It is a collection of standards that define how software should behave on Unix-based systems. Among these standards, POSIX also defines how regular expressions should be written and interpreted. In PHP, POSIX regular expressions follow this same structure and logic. There are actually two types of POSIX expressions, basic and extended. Both work on similar principles but differ slightly in their syntax and features. In POSIX regular expressions, the caret symbol, is used to represent the beginning of a string, and the $, $T, represents the end of a string. This means that matching will only occur within that specific portion of the data, and it will not continue beyond it. For example, if you use the caret before a word, the match will only occur if that word appears right at the start of the line. Similarly, if you use the $symbol, it will only match if the pattern appears at the end of the line. The structure of a POSIX expression is somewhat similar to a mathematical formula. You can combine multiple elements to form more complex expressions. The simplest form of a regular expression is one that matches a single character, but using different elements, you can make it match patterns, words, or entire sequences of characters. Brackets are used to specify ranges of characters. For example, the expression 0 to 9 matches any number from 0 to 9. If you want to match lowercase letters, you can use AZ. For uppercase letters, the expression AZ will match anything from A to Z. And if you want to match both uppercase and lowercase letters together, you can combine them like this, AZZ. These expressions are very powerful for defining search rules. For instance, you could search for all alphabetic characters in a string, or restrict a match to numeric values only. Although POSIX regular expressions are conceptually simple and easy to learn, they are slower compared to PERL-style regular expressions, which are more advanced and have become the standard in PHP today. However, understanding POSIX expressions helps you grasp the foundation of pattern matching and how regular expressions evolved in programming. Now that we understand how POSIX regular expressions work, let's take a look at the actual functions in PHP that use this style of pattern matching. In earlier versions of PHP, there were 7 main functions that allowed developers to search and manipulate strings using POSIX-style regular expressions. Although most of these functions are now deprecated in modern PHP versions, it's still important to know how they worked, since they laid the foundation for today's more advanced regular expression methods. Let's go through each one briefly. The first function is ereg. This function is used to search a string for a specific pattern. If the pattern is found, PHP returns a match. It's a basic search function that works in a case-sensitive manner, meaning uppercase and lowercase letters are treated differently. Next, we have ereg. This function works just like ereg, but it's case-insensitive. That means it will match patterns regardless of whether they are in uppercase or lowercase. Then there's ereg replace. This function searches through a string for a specified pattern and replaces every match with a replacement string. It's case-sensitive, so it treats uppercase and lowercase differently. The ereg replace function is similar to ereg replace, but it's case-insensitive. It performs replacements without worrying about capitalization. Next, we have split. This function divides a string into smaller parts based on a pattern. For example, you could use it to split a sentence into words using a space as the separator. The pattern defines where the string should be divided. Following that is splitty, which works the same way as split. But, again, it's case-insensitive. And finally, there's sqrregcase. This is a helper function that takes a string and converts each character into a bracketed expression that can match both its uppercase and lowercase forms. For example, if you pass PHP to sqrregcase, it converts it into POSIX, allowing the pattern to match any variation of uppercase and lowercase letters. All of these functions made it easier for developers to perform pattern-based searching, replacing and splitting of strings. However, as PHP evolved, these POSIX functions were replaced by Perl-compatible regular expressions, or PCRE functions, which are faster, more flexible, and far more powerful. So while POSIX functions helped establish the basics of pattern matching, The focus in modern PHP has completely shifted toward Perl-style regular expressions, using functions like preg match, preg replace, and with that, we've come to the end of today's topic on PHP regular expressions, where we explored the basics of regex, understood how POSIX expressions work, and looked at the different functions PHP offers for pattern searching and string manipulation. Understanding regular expressions gives you a powerful toolset for working with text, allowing you to search, replace, and structure data with incredible efficiency. Whether you're validating user input, cleaning up text, or building advanced search features, regex is one of the most valuable skills you can master as a programmer. If you found this video helpful, don't forget to support the channel. Stay informed, stay inspired, and join the Huzaifa TV official family. And before you go, make sure to like the video, comment your thoughts or questions, share it with your friends, and subscribe so you never miss an update from Huzaifa TV official. Thanks for watching, and I'll see you in the next video.